Okay, so one thing you're going to have to look out for when you're dealing with these problems is determining what kind of special right triangle it is. And that will be using your properties that you learned in the previous chapters. The first one is dealing with equilateral triangles that present special right triangles. So let's say for this example, number 1, if triangle ABC is an equilateral triangle, find the length of BC. Well, why would that present a special right triangle? Well, think about an equilateral triangle. Equilateral triangles have all three sides congruent. So that means that they have 180 degrees inside the angles here, and each angle has to be the same, so we have to split that 180 degrees evenly amongst three angles. So that means that each of these angles is 60 degrees. This whole big angle is 60 degrees as well. Now, if this is an equilateral triangle and you have a right angle coming here on the side, that means that this is also an angle bisector. So this angle, 60 degrees, has been bisected. So here is where we have our special right triangle, a 30, 60, 90 triangle. So now that we know it's a 30, 60, 90 triangle, let's use our new steps to solve for the missing side BC. So remember, the first step is to label each side as t square root of 3, and 2t. So side opposite the 30 is t, and that only includes DC this time, not this whole length here. Side opposite the 60 is t square root of 3, and the side opposite the 90 is 2t. The next step is to find the side that has a number next to it. So that's t times the square root of 3 equals 4. And we're going to use that side in order to find the value of t. So if t times the square root of 3 is equal to 4, then we want to divide both sides by the square root of 3 in order to find out what t is. These two cancel out, so you have t equals to the 4 times the square root of 3. Now that we successfully found t, everywhere we see a t, we want to erase it and replace it with what it equals. So here we have 2 times t. We want to erase our t and replace it with what we said t equals, which is 4 over the square root of 3. And when you're multiplying a number to a numerator, you multiply the numerators. 2 times 4. So this becomes 8 over the square root of 3. So the length of BC is equal to 8 over the square root of 3. Okay, in the next example, it says that AB is congruent to BC, which is congruent to AC. So all three sides are congruent in the big triangle, which means that once again we have an equilateral triangle. So that's going to give us 60 degrees here, 30 degrees here, because this one's already 90. Okay, so now that we've identified it as a 30, 60, 90 triangle, I want you to label each side as t square root of 3, and 2t. Then I want you to use that in order to find the values of x and y. So pause the video and see if you get what I get. Okay, so you should have gotten x is equal to the square root of 2 and y is equal to the square root of 6. This one was a little bit tricky, so I'm going to go ahead and work this out for you if you didn't get it. So remember, we're labeling t square root of 3, and 2t. So opposite the 30 is always equal to t. Opposite the 90 is equal to 2t. And opposite the 60 is equal to t times the square root of 3. So here we locate the side with the number next to it, which is the 2 square root of 2. And we want to solve this equation for t. So we're going to divide both sides by 2. So the 2 here cancels out, and the 2 over 2 here cancels out. So you're left with t equals to the square root of 2 only. Okay, now we erase and replace. Everywhere we see a t, we erase it and replace it with what it equals, which is the square root of 2. So that's how we get x equals the square root of 2. Now up here, we're going to do the same thing. We're just erasing our t and replacing it with what we said t equals, which is the square root of 2. Now, when you multiply two radicals together, you keep the radical, and then you multiply the two numbers inside the radical together, 6. You want to check your calculator and make sure it's not a perfect square. So for example, if I said this is the square root of 36, then I put that in my calculator, the square root of 36 is 6. So this is what's called a perfect square. When I put square root of 6 in the calculator, I get a decimal. So that tells me that I'm going to leave this as the square root of 6. So that's my value for y. The next special right triangle situation is when you have an isosceles right triangle. And the reason isosceles right triangles are going to present special right triangles is they're going to give us 45, 45, 90 triangles. So in this example it says figure HIJK is a square. Well, a square has 4 congruent sides and every angle is equal to 90 degrees. So I'm going to pull apart this triangle KIJ, and this is my 90, this is 6 centimeters, and then we have, because these two sides are congruent, this angle is 45 and this angle is 45. So right here is where my isosceles right triangle comes in, and where my special 45, 45, 90 triangle comes in. So now I do what I did before, and I use special right triangle to find the value of IJ here and JK here. So in a 45, 45, 90, we want to label each side as n, and n square root of 2. We use the square root of 2 this time because there's only 2 angle measures to choose from. So side opposite the 45 equals n, side opposite the 45 equals n, side opposite the 90 equals n square root of 2. Our next step is to find the side that has the number next to it and use that side to solve for n. So the side with the number next to it is 6, and we said that 6 equals n square root of 2. 6 equals n times the square root of 2. So once again we want to solve for n, so we're going to divide both sides by the square root of 2. Square root of 2 goes away, so we're left with n equals 6 over the square root of 2. Now it's erase and replace. Everywhere you see an n, you replace it with what it equals, which is the square root of, which is 6 over the square root of 2 here, and 6 over the square root of 2 here. Okay, so for number 2, this is also going to be an isosceles right triangle, and we know that it is because you have 2 congruent sides, because the square root of 2 is the same as the square root of 2, so that means you have 2 congruent angles. Okay, I'd like for you to pause the video and see if you get what I get. Okay, so the answer is z equals 2, and this one, once again, was maybe a little bit tricky because of the square root of 2, but when you label each side as n, n, and n square root of 2, you see that n equals the square root of 2, so we replace everywhere we see an n with the square root of 2, and the square root of 2 times the square root of 2 is equal to the square root of 4. And we always want to check to make sure that that's not a perfect square, because if it is a perfect square, then we leave it as the whole number that it equals. So if the square root of 4 is equal to 2. It's not a decimal, so that's when we do write 2. Okay, all that you have to do in this for this unit is, or for this lesson, is to do the exit quiz and then your quiz review. So because there is no practice worksheet, I'd like for you to pause the video, try these 4 problems, and just make sure you have the hang of it. And if you don't, raise your hand and let me know. But I'd like for you to pause the video and make sure that you're able to get these 4 problems correct. And then if you do, go ahead and go on to your exit quiz. Okay, so you should have gotten the following answers. If you did, you're ready to move on to your exit quiz and then your quiz review. Good luck.